Hey everybody, we're going to be talking about the third section of the Community Hurricane Preparedness module from MetEd. And let me go ahead and share my screen. And we're going to start here. So this is the second edition. You know, as I'm looking at this, I'm not sure if we have the second edition or that you originally done the first edition, whatever. If you go over here, you're going to go to the forecast process. So forecast process. And this is the screen that you should see. So we're going to start here and kind of step through a lot of these things and take really good notes. You're going to have to put a lot of stuff into here because I am going to give you direct questions that will require that you know this stuff. Okay, so we're going to be looking at this CARCA, right? This is a group at the National Hurricane Center, the NHC, which if you go over here, there's the National Hurricane Center. We are focused on the tropical systems in the Atlantic. Here, I can also do the East Pac, and currently we have this tropical remnants of Enrique, and then the Central Pacific. And if you go past Hawaii into the West Pacific, then it becomes typhoons, and then Japan takes over. So our Hurricane Center does most of these areas, the Atlantic and Eastern Pacific. Central Pacific, a little bit different. We're not going to focus on that too much. I'm going to focus on the Atlantic primarily. But that's the National Hurricane Center. And CARCA is the Chief Aerial Reconnaissance Coordination, all hurricanes. I am not going to ask you about this, so you don't even need to write this down. Okay, so, but what I want to do is I want to talk about all of this stuff. So I'm actually going to get my little Epic pen going on here because this is the stuff that's going to be super important here, are these things. And we're going to talk a little bit about each one of those. And this is actually a good review for what we've been doing. Now, in addition to that, these are all the things that are going to be going on to take observations. Once we get past observations, we're going to go into NWP. NWP stands for Numerical Weather Prediction. If you want to look at these terms here of the National Hurricane Center, Tropical Analysis and Forecasting Branch, Hurricane Specialist, and the Hurricane Liaison Team. Liaison is a person who goes in between. And I'm not really even going to worry about that you know these things. But I just understand this is part of the National Hurricane Center. The local weather forecast office, and then the emergency managers. So basically we're saying, how do we take all this information, make it go into numerical weather prediction? These are our models. And then how does that get disseminated down to the local office and then eventually to emergency managers? And that's what we're going to be looking at in this scenario, okay? Let's go to the next one. So observations, I'm going to skip through this fairly quickly. We're going to be talking about satellite, and I want you to go ahead and watch this little video clip here. It's just a minute, so you're going to be on your own site to do this. It talks about the GOES, the Geostationary Orbiting Environmental Satellite. That was a question on one of the assignments we gave earlier in the class. And there's basically three types of satellite imagery. It's a little bit more complex than just this, but there's visible. In other words, you're looking at how much light is coming back. Clouds are highly reflective, they have high albedos, and they're going to return a lot of light. And that's the visible satellite. Obviously, when it's dark, you're going to see nothing. There's the nighttime. Infrared imagery is based on temperature. So warmer something object is, the more radiation it gives back. We then do an inverse negative picture. And so hurricanes are going to be very bright on here because they're returning a lot of radiation. We can enhance it by giving it some colors, kind of fun stuff. And then water vapor imagery. Water vapor, as you know, the first thing about water vapor is that it's invisible, but the satellite can sense where the water vapor is. So it's invisible to our eyes, but the satellite can detect where that is. So those are the three things about satellites that you ought to know. Now we also have ship and buoys. Here's a good way to spell the word buoy. You should spell that correctly. But we can measure, especially when we're looking at water temperatures and wave heights and air temperatures and winds and pressures. Ships and buoys are really good. Okay. Then we have reconnaissance aircraft, and these are what's known as the Hurricane Hunters. So there is a video here that I'm going to kind of show you about the Hurricane Hunters, and we're going to go ahead and show this video. It's only 4 minutes, and I will talk through it a little bit.
Hang on to your butts. All right, here we go. We're about to go through some of the worst turbulence you can possibly go through. We're punching through the dirty side of Hurricane Florence in the Hurricane Hunter. You can already see us bouncing and bumping around.
This is the crew of the U.S. Air Force's Hurricane Hunter, flying through Hurricane Florence as it barrels toward the U.S. They're tasked with collecting the most up-to-date data from inside the monster storm. The information will help government agencies, businesses, and residents make critical decisions on the ground. WSJ joined the crew for the bumpy ride.
So I'm going to let you kind of look at this. We'll go forward a little bit.
Storm modeling and other technologies can't pick up. The crew is made up of Air Force reserves and members of the U.S. Coast Guard and Navy. They prepare for the flight and plot out a route before taking off at 3 a.m.
About 2 minutes to the box. They look pretty good.
The first few hours of the flight were dark and calm. During this time, the crew monitored for developments and prepared for the storm ahead.
I can't imagine going through a hurricane. I would be throwing up a lot. You don't have to put that in the notes.
As the morning sun broke through the clouds, the crew readied for the first pass through the storm's wall. To collect the data, the mission's loadmaster deploys a series of these cardboard-wrapped capsules called the dropsonde.
That's important. Dropsonde. So if you remember, we talk about radiosondes, which are launched from a ground site into the atmosphere to measure the atmosphere. Well, since they're already up there and setting up a balloon in a hurricane is probably not a great thing, they're just going to push this out of the airplane and measure temperature and dew point and winds and pressure as it comes down and falls into the ocean.
This is my station here, the dropsonde station. My primary job is to drop the weather instruments that give us a vertical profile from flat level all the way down to the sea surface of what that storm looks like. This is the actual dropsonde.
So there's just that little tube.
Through the launch tip. This picks up wind direction, wind speed, temperature, relative humidity, as well as barometric pressure. I press a launch button on the computer, and it opens up the valve to the belly point. The indicators are high wall, high wall going out.
Okay, so that's
Only the data
pretty
before it's
straightforward.
sent back to land. It's checked and adjusted by the onboard weather officer.
All the aircraft data is funneling into my computer here, so my job is to quality control, check it to make sure it's accurate, as well as the dropsondes that the loadmaster is releasing. That data comes to my computer as well. So I'm packaging all the data, and then I send it to the Hurricane Center via satellite real time, so they can know what's going on currently.
Okay.
The coast to reach the storm before passing through
So
the
if-
wall multiple times.
You know, you take a look at what they're doing. Here's sort of what it looks like.
The data collected on Tuesday's flight prompted National Hurricane Center forecasters to increase their estimate of Florence's wind speeds in an update less than 2 hours later.
Okay, so here's some of the products that we're going to be talking about from the Hurricane Center.
I've been flying into Florence since Monday.
We fly around the clock, so once one of these kicks off, we're flying 24/7 for probably 5 to 7 days at a time until the storm makes landfall.
So they're flying all the time. That's the Hurricane Hunters. They're going to be flying out of Biloxi, Mississippi. So if you want to watch the rest of that movie, we're going to continue talking a little bit about this. Here's a couple of the airplanes. Here's the big one that they fly through. And they do have some smaller aircraft as well. So kind of a fun thing. And you can look at more Hurricane Hunters over here. So what are you doing? I don't want you. Okay. Radiosondes, dropsondes. These are what we just talked about. Giving you that information, these observations. You saw in the airplane that they have radar. Radar is going to primarily see raindrops. Okay, so when we're on land or we're near land, we can see this might be a couple hundred miles from the radar site. And they can also tell you something about the winds that are going on in this region. So that's going to be weather radar. Now, ASOS, here's something you definitely need to know. Automated Surface Observation Station or System. And it's where, if you go past a small airport, all over Illinois, all over the United States, we have these ASOS sites that take information constantly. And they get fed into computers and weather maps and all that other stuff. So these are they're automated, although at the bigger airports like O'Hare and Midway, you also have a human being that's going to operate that site to supplement the data coming from the computer, because there are some problems with just a computer doing all that work. So there's all of your stuff that goes into these observations, and then those observations are fed into computers that run what we call numerical weather prediction. These are the things that we talk about models. Now, you may have heard the guy in the video talk about spaghetti plots. So we're looking at different models or different runs of the same model. And they're going to try to estimate where they think the hurricane or the storm is going. And there's definitely uncertainty. And then this white dot here is where the hurricane actually went. So these models are not super in terms of where things are going, although this is a really important diagram. So if you're going to do a diagram here for your notes, this is going to be one of those diagrams. And what this is showing you is how the improvement in terms of error, we have done 1990 at 24 hours. That's this red. We had an average error of about 100 miles in 24 hours. That means if we said, where's the location of the storm? Our models were off by an average of 100 miles. As we go into the year 2010, now we cut that in half. We doubled our ability to be more precise, to be more accurate. If you look here, the gold, this is 72 hours, or this orangish one, and we've improved on this. We're actually doing now 4 and 5 day forecasts, and it's kind of crazy, but we're actually at the point where the forecast we had in 24 hours is now as accurate as a 2-day forecast. So we've really, the key of this diagram is that we have improved our ability to forecast location of storms. So that's what you need to write down. However, this is kind of sad, is we're not very good at forecasting intensity. And if you look at all these lines being fairly straight, we're seeing that we haven't done a really good job of forecasting intensity. Now, this only went to 2010. In the last couple of years, we're getting some new techniques to get a little bit better, but we still struggle with intensifying hurricanes, especially those that are rapidly intensifying. That was one of the questions on one of the worksheets, is what kind of hurricane is most difficult? And the answer is a rapidly intensifying one. So we've had hurricanes like Hurricane Harvey that went from a tropical storm to a Category 4 storm overnight. So that's something to know about. Now, we do the forecasts coming from these branches of the National Hurricane Center. So again, CARCA, I'm not going to worry about that. I'm not going to worry about what the TAFB is all about. The Hurricane Specialist Unit, although there's information here if you're interested. A lot of these people, I know some of them, they're fun people, but they're really geeky into hurricanes. You've got your local weather forecast office that plays a role. By the way, this is, if you ever see a building that looks like that, that's where they launch radiosondes. But here's your liaison team. So these are going to be associated with federal, state, local emergency managers, FEMA, forecasters. A lot of times the media becomes a part of this, and they discuss things. They make sure that everybody's up to speed on what's going on. This is really huge. They've got these huge rooms for the major hurricanes where people from the fire department, or maybe from local emergency managers, or if you imagine that you had power companies. All these people are coming together so that you coordinate the response to this significant emergency. And the emergency manager, which we've talked about all semester long, is really dealing with how do we go to the local level. Now you have FEMA on the national level, but ultimately it's the local emergency manager who's coordinating the efforts in their individual town. Okay, now products. This is important, and I actually am going to need you to study this and know this. So, and there's a lot of information here, so we'll go through it a little bit slowly. First of all, we're looking at local products. So what are the local ones? Well, we've talked about the HWO a bunch of times. So obviously, if you have a hurricane coming into your region, the hazardous weather outlook is going to be an important part. Then they're going to still be doing the forecast. They might do some watches or warnings that are inland, like flood watches or flood warnings, but this is not specifically hurricane. The one that's super important is this guy here, the Hurricane Local Statement, the HLS. You definitely need to know that one. That is a special statement about a hurricane that comes from the local NWS office. That is, they know the area really well. They're like, hey, you know what? At this bridge or in this location by maybe this grocery store, these are things that are coming out. So they're going to give local people information, and that's why it's a local statement. Other than that, everything else is coming from the National Hurricane Center. So if you look, all the rest of these are National Hurricane Center products. So a couple things that we look at, and we're thinking about this in terms of time and specificity. So tropical weather outlook is going to be a big thing. And anytime you have an outlook, you need to think that's an extended forecast. Hazardous weather outlook, up to 7 days. Tropical weather outlook, into the future. We then have some of these things, which we'll get into a little bit later. We're talking about storm surges as it's approaching. And notice we have a point where we have to make an evacuation decision. And then we have warnings and surface wind fields that are coming out as this thing is about to hit land. So we need to know the difference between a hurricane watch, which is 36 to 48 hours, and a hurricane warning, which is less than 36. Really important that you remember that distinction, which we have talked about in previous parts of this class. Okay, hold on a second. Now, tropical weather outlook, and again, this is a long section in the module, but I don't need you to read everything, but if you want to glance over it, that's fine. But again, we can look, and if you even look here, here's the outlook. Here's something that's coming up. Potential tropical cyclone 5. These are the outlooks that are going on here in the Atlantic. So here's your 5-day graphical outlook. And that's what it looks like. Okay? And that's just a way to stay together. And they do have graphical outlooks as well, where they give you some, here's where these waves are coming out. Now, the hazardous weather outlook we've already dealt with, so I'm not going to go through that again with you. Tropical cyclone public advisory. The key idea on this is anytime you see the word public, you have to understand who's the audience. It's the public. They do not have technical experience. They do not know a lot of things about stuff. So it's very simple, very basic, so that the public becomes informed. Maybe well-known reference points. How fast are the winds? What's the pressure? Where's the track going to be over the next couple of days? Okay, so public advisory, keep that in mind, okay? When we go to the next one, the forecast advisory, okay, now we're giving an advisory at this point. So this is going to have a lot more technical information, and they're going to give you a lot of things. thing that you need to know is that this is what you need for HURAVAC. HURAVAC, if you've done your module reading, is the Hurricane Evacuation Plan. It's a model to help emergency managers and the Weather Service determine where there's going to be an evacuation. Where does there need to be? So a lot of information goes into the forecast advisory. I would probably think you probably don't do much with this one. It just summarizes it, gives you some of these mathematical ideas of where it is, and that goes into the final product of this advisory into HURAVAC. Now, if you see the word discussion, a discussion is always going to be technical. This is for the Weather Service and people who understand what's going on. So there's a lot of information about maybe bands or maybe eyewall regeneration cycles and all these other things. And then they give you how strong do you think it'll be, 100 knots, 105 knots. Then it's inland and it goes to extratropical. So that is like, for me, because I'm a weather geek, right? I'm going to go take a look at the forecast discussion to find out more about what the thinking is. Now we have a lot of graphical products. One of them is the forecast cone. And the cone, this is the cone of uncertainty. This white area is up through 3 days. And then this other area is 5 days. And notice as you go further into time, it gets a lot more spread. Remember, there's more air as to where this is going to be. But originally, we think this is where it's going to be a hurricane. It may say a storm, tropical storm. It could say have the letter M in it, which means it's a major hurricane, category 3 on the Saffir-Simpson scale. And it shows you graphically where we think is going on. They're also going to put out watches and warnings, both for the hurricane and tropical storms. So that product is really important if you want to look at this and get a quick summary of, hey, what's coming down? Okay. Then there's wind speed probabilities. Gee, this makes sense. And there's 3 different levels of probability. Tropical storm force winds, which is 30 miles an hour or 34 knots. You have 50 knot winds greater, and then you have hurricane force winds. So it's a probability, simple as that. And see, you're looking at almost 100% probability of tropical storm force winds on this example moving into Texas. If I look at hurricane, there's a probability, but it's not as certain in case something goes wrong. So that's the wind speed probabilities. Storm surge probabilities, I think this is kind of the same thing. Notice that this says slosh. I think you need to know slosh. Slosh is a model that predicts how much water is going to inundate the shore. Remember, inundate means to come onto land. So this is a model that helps predict how significant is the storm surge. Remember that storm surge is the most catastrophic killer when you're near the shoreline. Okay? So you see this, and I think in the module, there's some stuff on meows and moms and all sorts of fun acronyms there, but those are the ones I want you to know. We also have a surface wind field. This makes sense. Where are the winds? How much of them are hurricane force now? How much are tropical storm force? So you see, Louisiana is about to get hit by tropical storm force winds because they're extending way out from the center of that hurricane. Okay, then you've got your area forecast discussion. Again, it's a discussion, it's technical. This is coming from the local office, which is kind of focusing on what's happening locally. So that's your WFO. That's where that comes from. Then your HLS, your Hurricane Local Statement. And it's kind of good. You see how all schools in Matagorda County will be closed on Thursday and Friday, right? The Hurricane Center is not going to be able to keep track of this, but local weather service forecast offices ought to. Okay, so that's a really big text product there. And then here's your watches and warnings. And again, take a look at this. These are your watches and warnings, both for tropical storm and for hurricane. Okay. Now, some questions out here. I want you to go ahead and do these. These are going to be important. And this one is a matching, question 4. So I want you to incorporate the answers into your notes. Try to get these on your own. Make sure you know what they are, because those are the products that we just went through. So all these questions are really important. And there's a couple tricky ones in there. So make sure you know the answer in case I put one of those tricky ones on the test. Okay, so that is what you're going to be looking at there. Those questions are really important, and I will give you this on a test. So, because I want you to know what those products are. And when we go to the products, you know, the original page again, there it is. And it looks a lot more complex, but it's really not too bad. I think you should be able to do fine with that. So that's a little bit of a look at the forecast process. Now, if I wanted to go on further, I do kind of want to look at a little bit on emergency management here. So here's some of the evacuation studies. Some of you are doing hurricanes, and you might want to look at a hurricane evacuation study. Here's your HUREVAC of what that is. I would say, why don't you type that or write that out and say that's a good definition of HUREVAC. I'm just going to go through this as quickly as I can. A lot of hurricane evacuation studies. Again, this goes into this idea of answering questions. Who's going to be impacted? Where are they impacted? When are they going to have to leave? So this is something important that I think you should understand this. Where are the areas depending on the strength of the hurricane? How vulnerable, right? Vulnerable populations. Now let's think about this. Write down what you think are the vulnerable populations. So go ahead and pause me. Write down what you think the vulnerable populations are. And I'm going to look at your answer for points, okay? And I want to see what you think. I'm going to tell you the answer, so just hit pause, and then when you start up again, I'll tell you the answer. So populations, obviously elderly people are going to be vulnerable. Maybe children are not as vulnerable as you may think because they should be with family, but people who may be injured, maybe the poor. Did anybody put the poor are a vulnerable population? They don't have means to transportation as readily as maybe other people. Here's another one. What about prisoners? A lot of times you have prisons that are going to need to be evacuated. How about people in hospitals? Those are all vulnerable populations. What about people who don't speak English? Or in the United States, maybe not Spanish even, but maybe there's European people who don't have a good grip of the language. Remember we said tourists are a big problem? So if you're giving them evacuation orders, they don't know where anything is. They're reading a hurricane local statement. They have no idea where anything is locally. So those are all vulnerable populations. We can do behavior analysis. This is kind of interesting. So here's a study that was done. If you had a category 1, 42% would evacuate the home. 52% would stay home. I think that would be important if you're an emergency manager to say, well, who's staying home? Where are they going to be? The stronger the storm, the higher the likelihood that they're going to evacuate. But there's always people who will not evacuate. Something really important is when there's an eye wall warning, a lot of times when the eye wall's hitting, you call 911 and 911 will not respond. Now think about that. You live in America, and anytime you dial 911, you're counting on somebody to respond to you. During a hurricane, during the eye wall warning, there's no one coming. So when they say you need to evacuate, this is really important, or else you're on your own. And it's amazing how many people die because they think they can do something that they can't do. So, but you can't force someone to evacuate. You can look at this behavioral response curve. Some people, like, here's the evacuation order. Some of them are already like, I'm going out. But some of them take a long time to figure it out, to get out of there. At 50% of the people on a long response takes 4 or 5 hours to figure out they're going to evacuate. Others are like, yep, I'm gone. 1-2 hours, I'm gone. You don't have to tell me twice. Then you need to know where they're going to go. Most people go to friends or relatives or hotels, or they go to some community center. Some go to a public shelter, but not many. But you need to know this because if you're working with FEMA or you're working with emergency management, you need to know how many beds, how much food, how much water to provide for people if they're going to evacuate to a public shelter. So these are all considerations when you're making plans. There's a lot going into it, and it's a really hard thing because it doesn't happen all the time. Next one here is transportation analysis. Yeah, how do you get people out? Charleston, South Carolina is probably the slowest evacuating city. There's not that many exits from the city. So Charleston might need to get evacuation order 48, 60 hours ahead of time just to get people out. Because remember, and write this down, you want everyone evacuated. We want the evacuation to be done by time tropical storm force winds hit. You ever been out to the intercoastal, big bridges, very windy, kind of scary, and tropical storm force winds. So that's the goal. And you need to know something about the road. You need to know how many tourists, what are the traffic flow. A lot of times you have contraflow. So you say, hey, all 4 lanes on this highway are going one direction. So lots of planning has to go into that. So there's some information in here, post-storm assessments. I'm just kind of looking at stuff like this. HUREVAC, lessons learned. We always talk about things like this. And remember, there's a huge amount of uncertainty, right? These big air cones, the forecast cones have big error. And if you evacuate too many people, you cause yourself a problem. So you really want to pinpoint who needs to evacuate, what's life-threatening, how can we get this? If any of you are doing Hurricane Harvey, that was a tough one. So some things to think about in that scenario. Hurricane Harvey was interesting because there was so much flooding and the governments didn't know whether to send people away or keep them in their homes, and it became a real mess. Now there's one more section here on decision making. It's just sort of a scenario. And I think I told you a little bit of something on one of the assignments, but if you're going into emergency management, this would be a great module to look at. You can maybe take a look at a summary. This might be something worth printing out and kind of putting into your notes. And that'll be good. So talk about hurricane plans and making good decisions and what kind of information you need for that. Okay, so stop to share. That's our hurricane. So those are the 3 parts of the hurricanes. I thought this one's a little bit shorter. It should be a little bit better. But we're giving you lecture notes breaking up into 3 parts. So hope everything's good. Now for you guys in class, there should be one more med ed, and that's tsunamis. Okay, so you guys have a great day, and we'll talk to you later.